Hello guys, welcome back to Math with Mitchell, and today we're going to be going over matrix operations. So first is addition, and this is very similar to just normal addition with numbers, and in that you multiply or you add the first or the row, or would be row 1, column 1, with the same row and column as the other matrix you're adding it to. So if we were going to add matrix A plus matrix B, it would look something like this. So A is this, as you can see here, 5 plus 1, 4, -6. Now I'm going to do some notation here to sort of help us out. And so this would equal A11, which is column 1, row 1, plus B11. That would be the our answers 1, or column 1, row 1. This is A of 2, 1, second row, first column, plus B's here. B's 2, 1. And then our next one is going to be A 1, 2, first row, second column, plus B's 1, 2. And the last one is going to be A 2, 2, plus B of 2, 2. So that's what the answer is going to look like. And so if you actually do it out, you end up with 2 minus 3, 1 plus 4. Then you get 3 plus 1. And minus 5, minus 6. 6 is there. Not good here. Minus 6. So then your final matrix is going to equal to -1, 5, 4, and -11. So that's basic addition. It's basically like adding numbers, but you got to remember that you add the row and the column numbers that are the same in each matrix to each other to get the same location in your final matrix. Now the big thing to know is that you can only add matrices that have the same dimension. So sometimes you'll see the notation A is 2, 2, which means it's a 2 by 2 matrix. You can only add matrices that are the same dimensions, okay? Or sometimes 2 times 2, you see that. So since B and A are the same dimension, you can add them. But if B was a 2 by 3, it would not be possible. And your answer is going to also be the same as the same dimension as your same as A and B, with the dimension of A and B, which in this case would be 2 by 2. Let's move on to scalar multiplication. So scalar multiplication is a different operation you can do on matrices, and that's usually in the form of some scalar, like being any number in the real number system, so 1, 2, 3, 4, 5, etc., times a matrix. So let's make up a matrix here. -3. Sorry. 4. So basically multiply a scalar by any matrix. This can be any matrix. And it can also be in any dimension. So it can be a 3 by 2, a 3 by 3. I'm just using 2 by 2 because that's usually a great way to show how a concept works. But basically you multiply this number by every single element in your matrix. And so say if our scalar was equal to 3, our final product would be 3 times this matrix, which we can call the matrix A, but I'm just going to use examples here. Because sometimes you'll see like scalar of A or 3 of A be the same thing if this example matrix was A. And so then your final product is going to be the multiplication of each of that scalar to each element, which is going to be 6, 9, 3, and 12. So that's going to be your final answer for scalar multiplication. Now the big thing to remember is scalar multiplication is different than normal multiplication of matrices. That's the next thing we're going to do is the multiplication between matrices. And so since that's scalar, which you can do with anything, and now let's go to multiplication. Now also I want to cover real quick before we move on to that is that addition is the same thing as, you can do the same thing in subtraction. It's the same concept except that you're subtracting the terms instead of adding. So this would be, these would be minus signs, but it's going to be the same concept. But you'll see here that there's no division of matrices. So it's only multiplication, addition, and subtraction. So here we have two matrices that we're going to multiply together. They're the same as our last example. But the basic form for multiplication, this is not standard, so pay very close attention, is that you need to first make sure that the matrices can be multiplied together properly. So if you see, this is a 2 by 2. This is a cool trick I use a lot. And this is also 2 by 2, so that's dimension, which is row by column. First number is always a row, second number is always a column. If these two terms here match, they're the same number, which in this case they are, then it's possible to multiply them together. Your result is going to be the outer two terms. So that's going to be the row of the result. This is going to be the column of the result. Now, remember, this is very key, is the order does matter. So A times B is not equal to B times A. That's a huge difference between multiplication in the real number system and multiplication in the matrix system. Is the order does matter. And you can sort of see that this rule only works if the order does matter. So since we have the same, since the insides are the same, 2 and 2, this is possible, and the outsides are 2 and 2, so our final matrix is going to be a 2 by 2 matrix. So let's do AB. So this is what AB is going to equal to. So it's going to be equal to A. Let's draw it out here. 3, 1, negative 5 times negative 3, 4, 1, negative 6. And it's going to equal 2 by 2. So that's what we said originally. So now, this is kind of the interesting part, is we take the row of this first matrix and the column of the second matrix to find this element. And so you're probably like, well, how do we do that? So first we multiply the first two terms, or the first term in this row, which would be 2, and the first element in this column, which would be negative 3. So that would be negative 6. And then we add it to the multiplication of the second term in the row, the second element in this column, to equal 12. So the answer for this element right here is going to equal 6. So we'll do that again with another element. So say if we wanted to find this element, we would take the bottom row here multiplied by the same column. So that's going to be 1 times -3 plus, I should probably do dot here. So dot and multiplication, dot and the x are the same thing, but because in algebra they do the dot because they don't want you to be confused with the variable x. And then you do -5 times 4. So then this will equal -3 plus -20, so -23. So that's going to be this element. So then to find this element, we're going to take the top row again, multiply it by this farther column. So let's do that down here. So it's going to be 2 times 1 plus 3 times -6. And that's going to equal 2 plus -18 is going to be equal to -16. And then this last element is going to equal to the bottom row of the first and the last column of the second. So that's going to be 1 times 1 plus -5 times -6. Oh, that didn't turn out well. And so that's going to equal 1 plus 1. So that's 31. Right. So then your final matrix is going to be all these terms compiled. Yeah, -23, -16, and 31. So that's going to be the multiplication between A times B. Now B times A would be a different result. I didn't check to make sure that it would be a different result, but most times, or it is a different result. Sometimes you have special cases where it is, which we'll talk about later in other videos. But the big thing is to know that the order does matter for multiplication between matrices, and you got to make sure that the matrices can be multiplied together using this fancy rule here. And that's basically it. Those are the 3 main types of operations you'll do in matrices. Remember those rules, and good luck.